Time for an update. It's been about 7 months since I set all of these off. The dandelions have grown quite well. It's not been on a windowsill because the pot was a bit too big, but it has been fairly close. So it's had a little bit of sunshine and I have kept it watered. This is basically just garden soil, so it's to be expected that there's stuff growing and living in it. At the back here are the wooden lollipop sticks. That's quite stiff. Well, they haven't rotted at the base, but there is evidence of some mould growing on that. I think they'll probably go eventually. But what else have we got in here? These are the Polycaprolactone, and they haven't seemed to have done a great deal. So maybe there's not enough of a community of microbes in there. I'm seeing a little bit of mould on the very top of that one, but it doesn't look like there's anything happening deep down. This one here has got some mould growing on it. This is one of the Cawiton sticks, which is a starch PLA blend, I think, and that's definitely a lot stiffer at the top than the bottom, and that is feeling a little bit weaker. Certainly at that point there, that's actually starting to shear off. So something has happened. I suspect that's just the starch that's being eaten. I'll leave that out actually and have a closer look at that one. What else have we got in here? These are the FKuR material. This is another PLA, and I'm seeing some evidence of cracking there, and it's splitting apart. So that's probably, and there's a bit there that's fragmenting off, and again that's very soft and flexible at the bottom and still quite stiff at the top. So I think that's probably the starch that's being eaten away on that. I don't think the PLA itself is probably going. In here, what's this one? This is the polyhydroxy butanoate, and yeah, again that feels a bit stiffer. Interestingly, it seems to be the top bit where they come in contact with the soil that most of the damage is being done. But we'll have a look at that one a bit closer. What else have we got in here? This one, ooh, that's completely broken off. That's PVOH, which is to be expected. These are going to need a bit of a clean up before we can study them, so we'll have a look at that. And this one here has gone quite significantly. These are actually polycaprolactone with a PVOH, and that's quite, yeah, that's the PVOH soaking up water, but there also seems to be quite a bit of degradation on that, so we'll have a close look at those. What else did I do? All those. I'm going to get that Cawiton one out and see if we can have a look at the mould that's growing on the top surface. But again, it's a lot softer at that interface point, so we'll have a look at that. But the wild card ones, which I wasn't really expecting, are these, which have completely rotted at the base. That is very fragile there, and obviously this was quite a bit longer. These are the Bioplast material, which I've had kicking around for a few years. This one is the grade GS2189. These are done by a company called Biotec in Germany, and they have quite an extensive range, well, probably about 8 or 9. They don't tell you exactly what's in it, and they don't really show you any pictures of their stuff degrading. It is certified as compostable. Here's another fragment of it from a cable tie I made, and again this is completely gone at the base and being chewed up quite significantly. So even though this is supposed to be only compostable, clearly something is happening just in soil. And here's another end piece, oops, if I can grab it, which is broken off at the bottom, and this is still at the top, still quite flexible. So something is going on underground, and I don't even think I can find the bottom parts of those. They're somewhere in the soil. So there's been mixed results really. Some of this has gone, some of it is showing signs of going. The problem with a lot of these blended materials, of course, is you don't really know what's actually in them. You get a rough idea, and Biotec do have quite a lot of patents which gives us an idea of what's in there, but nothing very specific, unfortunately. So anyhow, after 7 months in soil, there is some evidence of biodegradation going on. Whether it will go to completion, because the PLA stuff doesn't normally go this cold, and this has probably been sitting at around, I don't know, over the winter, probably 5 to 10 degrees. It's been a little bit warmer over the last few weeks, but certainly not significantly above 15, 20 degrees in here. It's surprising that the Polycaprolactone hasn't done more, but a lot of it is down to what's living in there. So anyway, let's move over to the microscope and have a closer look at these and see what's going on. This is the Cawiton material, some of that mould that was growing on the top surface. There's really not a great deal to see there, unfortunately, and it doesn't look like it's doing anything to the surface of the material. So if we come down a little further, this is probably about where it was just coming out of the soil, and there's certainly some green stuff growing there. That's possibly an algae maybe growing, or something like that, a moss on it perhaps. And there is some cracking and some more cracking, but it's not really showing a lot of evidence. I can still see swirl marks from the polymer. I think that's just an air bubble, so not particularly convincing really. Nope, there's absolutely no significant evidence of any biodegradation going on with that one, unfortunately. This one is the FKuR F1100, and again there's some evidence of cracking on the surface. Something's having a go at eating it. Is that a chunk taken out? That looks quite conspicuous. That might be where it's flaked off. There's some slight cratering going on there. Don't know the exact composition of this material. It's a PLA blend, probably a glycerin as a plasticiser or a sorbitol or something along those lines. I doubt it's anything spectacularly exotic, and then there'll be some starch in here, I imagine. But seeing slightly more evidence of microbial attack, but that's about it. So maybe if I left that a bit longer, there is some sort of erosion going on the surface, but it's marginal, I think. So okay, let's have a look at another one. Now, this is interesting. This is the PHB. Oops, I've lost it. Where's that pulsating stuff? I have no idea what that is. That is weird. There's something living on that, but it's eroded the surface quite significantly. This is a pure material, so the fact that this is going at all indicates that this would go completely if we left it long enough. That is very strange. I wonder what that is. There's definitely something pulsing and oozing in there. Oh, there's a worm. I'm seeing a worms. So they're nematodes or something growing in it. There's one at the top of the screen there, you can just see. Interesting. And some more. So this is basically riddled with worms. But there's quite a lot of erosion. You can see there's some cratering going on. Interesting. Let's get a bit of a focus on that. Well, I'd say that so far this one definitely looks like it's biodegrading in just common soil, and that's to be expected because this is produced by bacteria, so they have the necessary enzymes to make this stuff, basically as an energy reserve, the same way we make fats as an energy reserve, and a lot of plants make oils. Bacteria make this stuff, and of course they have the depolymerases as well to break it back down when they're hungry. But that's definitely showing some signs of biodegradation. It's not an easy material to work with, unfortunately. It's not very strong, and you've got to be careful not to overheat it or it turns into a sticky gloop. But yeah, this stuff definitely does seem to be biodegradable in common soil. Right, this is the Polycaprolactone mixed in with some polyvinyl alcohol, and there's something there living in the soil. I don't know if it's having its lunch, but this is pretty horrific. I think that's just soil stuck into it, but it has been seriously chewed up. And that's to be expected because the PVOH is going to absorb water and melt, but it's also going to expose the polycaprolactone to attack. I know from previous experience PCL is biodegradable under these kind of conditions. Wow. So blending the two, although I seem to recall it didn't mould very well, but if you can blend the two, then that seems to be a pretty reasonable biodegradable compromise, because the materials definitely are known to degrade under ambient conditions, and simply by adding some polyvinyl alcohol, it looks like we can kickstart that to a certain extent and get it to disintegrate a lot quicker. Try and get a bit of focus on that. Again, I'm seeing some kind of activity in the centre there, some bubbling stuff, so possibly there's more. Yeah, right there at bottom centre there was something wiggling around in that, so maybe more worms living in it. I think the resolution on this screen is probably about 3mm across. Give you some idea of scale. Could really do with a slightly better microscope for this. But yeah, that definitely seems to work. So polycaprolactone blended with some PVOH. Maybe I can find a slightly better recipe, but that's a candidate. And our final exhibit, this is the Biotec stuff that unexpectedly is showing quite a lot of degradation. It's seriously pitted. I'm not getting a terribly good focus on this. Let's see what we can do. No, that's not liking that. Maybe I'll turn it over and we can get a look on the other side. Come on. There we go. So there's a lot of cracking, a lot of surface erosion. Definitely something's being eaten away, but it might just be the starch, because this is the stuff that smells of popcorn when you mould it, so it is quite starch rich. A big chunk missing there. So whether anything's happening to whatever the substrate is, some of their patents mention PLA, some of them do mention polycaprolactone, but without knowing the exact composition of this, it's difficult to say. A lot of staining. It's reminiscent of polycaprolactone, so maybe that is their magic ingredient. Let's have a look at another one, see if I can get that one. Yeah, that's another bit that's gone. Quite a lot of degradation in there. That's the clean bit. Bring that under. Interesting. So, that stuff does go. Certainly I think if anything made out of this stuff got into the environment, then it's going to go. It's not like it's leaving big chunks, microplastics. I suspect there might be very small fragments in the soil, but I'd expect they'd probably get eaten up eventually. Have a look at that one as well, just for good measure. See if I can focus on that. Yeah. Now, in the centre there, you might be able to see some black pointy hairs. And I've seen this before. I'm not sure I can zoom down any closer. Let's see. No, that's not liking that. I think zooming out isn't going to help. Need a better microscope. Now I've lost the hairs. Where were the hairs? There we go. There's some of the hairs. See those sticking out. Now they're growing out of the plastic, and I'm pretty sure that's a species of mould called ceratocystis, which is a common plant pathogen. I think it likes to feast on sweet potatoes. I don't know if there's any evidence of them eating normal potatoes, but obviously starch-rich material is something that they do consume. There they are, evil-looking black hairs. So something is definitely living in the plastic and sprouting out the top. I could really do with a slightly better quality microscope to get in on these, but I suspect they're probably, I don't know, a couple of 100 microns long. But yeah, that's definitely proving to be a free lunch for something at least. And there's some more of them. Interesting. I'd really like to know what the composition of this material is now. I'll have to do a bit more digging. There's another one. There's the ones we just looked at. Oh, that's something interesting. I don't know what that critter is. Could that be another mould? Or could that be the same stuff, just in a... Oops, losing it. Oh, come back there. I need a stage as well, don't I? There we go. Let me see if I can get a slightly better look at that. Wrong way. Oh, this is all backwards because I think my microscope's twisted. Okay, hang on. Let me see if I can get a close-up of that. Right, that's about as good as I can get it. It's definitely something interesting growing there with more hairs on it. I suspect that's another mould. Might even be the same as what we're seeing with the black spikes coming out. Weird. It's a different world down there. But anyway, that's where we're at the moment. I've got some more tests on the way at the moment, so I shall do an update of those in due course. But do some of these biodegradable plastics degrade in the environment? It seems some of them do, but I think there needs to be a bit more transparency in terms of what's exactly in the materials. So there we go. Fascinating stuff.